Welcome to this comprehensive step-by-step guide to R for data science engineering. So in this section, we're going to focus on R. Other sections we focus on Python, but this section is specifically for R. But what is R? R is a powerful programming language designed specifically for statistical computing and graphics. It has got a ton of libraries and frameworks tailored for data manipulation, data cleaning, data visualization, and data modeling. It has got a wide open source community. And when it comes to statistics, I will go with R than Python. Now, there's discussions out there where people say which one is better between R and Python. I would say it depends on the project at hand. If your project is more on pandas or numpys, I would say go towards Python. When it's more statistics, go with R. But still, it always depends on the project at hand. Anyway, let's go ahead and install our R. I'll just walk you through how to install R. So the first one is to go on Google and search Anaconda Navigator download for Windows. So it will take you to this sponsored and this one. Click on it and click download. You have to enter your email. Then when you submit, that link will be sent to your email that you can install. So that's number one. Number two is to go for R on Cran. So you just say R for Windows, download. So you go right here, download for Windows. So if you come right here, it depends on your system, but you click Windows, then you have the file sent. It's going to be downloaded, then you can install it. So that's another approach. Now, if you do the Anaconda one, which I'm using right now, you will, after you install Anaconda, you will have this menu where you have all the softwares that you might need in data science, even in programming. All right, so there's PyCharm, which we want to use for Python, and there is VS Code, which you can do almost any literally almost any language that you can think of writing. You can write them in the VS Code. We have notebook here, Jupyter Notebook. We have we have R Studio right here. So you can install click right here, install R Studio. It's gonna give you an R pad like this one where you can just click launch. But for me, I don't want to use this one. I'm gonna use a Jupyter Notebook. So you can click on launch on Jupyter Notebook. All right, so I have it open already. So this is my Jupyter Notebook. And you can see if I go to the home page here. Let me restart my home page. All right. So if I click new, I have an option to write a R notepad or Python 3 notepad. So to be able to have the option for R, all you need to do is to go on your start and say Anaconda prompt. So after you get this one, you get an interface like this one. And from this interface, all you need to do is let me maximize it a little bit, is to enter this command, which is right here, conda install space C space R, then IR kernel. So once you run this, you're gonna be prompted to say yes. Just say yes. Then you install. Then you get a prompt saying done. And then after that, you have installed R to your Jupyter Notebook, and all you need to do is to close your notebook and restart it again. All right. So now you'll be able to create an R Jupyter Notebook file. Perfect. So that's your basic introduction and a step-by-step guide for installation. Now, assuming that you installed correctly, let's talk about basic R syntax or arithmetic syntax. basic arithmetic, variables, data types, vectors, list, matrices, and data frame. All right, so this is an R file, so we can simply just type you can use it as a calculator. 2 plus 2, when you run it, 4. So you can do 2 times 2, actually, yeah, 2 times 12, so that you can have a different number. You can do shift enter. You can do shift, like you can see here, shift enter, or you can just run it here. All right. And again, we can do simple arithmetics like 14 divided by 7. So it will give you the answer right here. Now, if you don't know how to navigate Jupyter Notebooks, there's a video in my timeline that walk you through all these, what you can do with all these symbols and all the file menu, anything that you need to know about Jupyter Notebooks. But basically, you can do text, you can do code files, you can do markdowns, which is a markdown right here. You can do code cells, and you can see your results right there, right under the code. All right. So that's your basic arithmetic. Anything that you can think of in arithmetics, you can do it in R. So you can do minus. Then let's go ahead and do variables. Variables are the same as Python. The only difference is how you, let's say, edge, how you write the syntax. So you use this and say, let's say 30. Then you want to print edge, it will give you 30. So we can also say height is equals to 6.2, print height. Perfect. And I'm just going to add another cell here. And you can also do something like this. Z is equals to, let me see if I do edge times height. If there's any mathematics like this, yes, you can do something like this. Then you can have the result, which is 30 times this one. Perfect. All right, those are your variables. That's how you assign your variables. And let's talk about what we call data types, such as a number, which you've done already. So we can say num is equals to 10. So you print num, you can say num and run the code, or you can just say it will work the same. It will just work the same. All right, so let's do characters. So let's say we want to do hello world. Then I want to print this character. You can just say character, or again, you can repeat in a print function. So it will print that text, hello world. Alrighty. We can also do something that we call Boolean. Boolean is a true or false, a 1 or a 0. So we can say is student. Then you can assign it. You can do true is graduate. You can assign it to false. So on a print is true, is student rather. So it's gonna print true. And if I do is graduate, so it's gonna print false. It's just basic. If you have seen my introduction to Python video, it's the same. Only the difference is how you assign variables, and but the core concept is the same. All right. So there's also functions and loops. We're gonna do functions and loops in Python. Actually, let me add more here, and let's talk about vectors. So my vector, that's the variable name that I just want to assign it. My vector is equals to C, let's say 20, whatever number that I want, 30, 40, 50, perfect. I want to print my vector. So we have another data type, another, which we call vectors right here. And we can add a new cell. Let's do lists. So I can do my lists. We can assign it like this again. Then you type it list. Then let's say name is equals to John. Then age is equals to 30. Then you close. Then you want to print my list. So same thing is going to give you name is equals to John, age is equals to 30. All right. So let's also do matrices. So 1, 2, 3, 4 matrices. Now these are the matrices that you know from your high school math. And on matrices, I need a below another one. On matrices, all right, you do matrix or main matrix, you assign it with an X. So 1, number of rows. So you do n row. You can do, let's say, 2. And I want to print it, my matrix. So I've specified the number of rows. 1, 2, I can do 3 here. 1, 2, 3, 4, 5, 6. And I can do, let's say, 24 here. I can do my 3 rows, 1, 2, 3, 4, 5, 6, all the way to 24. In number of rows, I want 3 rows. All right. Let's do last one. I want to do what we call data frames. So did assign it. We can do data.frame. Now data frames, it's a very familiar term that we're going to use when we do our projects later. But let's just introduce the concept here, then we can use it later. I can do score is equals to C 90.85. Yeah, then I can print data here. So I'm saying A is equals to 90, B is equals to 85. Print data, A 90, B, and I can keep on adding and just say C here. And then I can do 99. Then if I run it, it's going to just keep on adding. And if I want to add one more, whatever I want to add, a name, score, maybe age, is equals to 12, 34, 56. I need to close this one. So you can literally keep on building your data frame. Just keep on doing like this, and you can actually build your data frame in data science. Is basically your Excel file, your rows and your columns. So that's basically what you're creating here. All right, let's discuss quickly functions and loops. Then we're going to move on to the data science part of it. All right, so We have a basic function here, which is myfunc. I want to assign it. It's an empty function, nothing in here. All I need is just for it to print. This is my first R function. Then I have to call myfunc one more time. So when I run it, this is my first R function. That's a basic function, or I can add some arguments here, A and B. So myfunc is equals to function A and B. I want it to return A and B. I want it to print whatever I want to do, my function to do. So let's say if I enter numbers here like 30, 31 and 45, it's going to return A plus B, 31 plus 45. And if I run it, it's going to give me the number. Let's do a basic loop. For I in range, let's just do a simple range 1 to 10 here. All right. Print I, return every number within the range 1 to 10. So it's going to return everything within from 1 to 10. If I say to 5, it will return anything from 1 to 5. All right. So let's import data. So if I go back right here, I have a file somewhere in here that I called data_1, which is a CSV file. So I can access that file, which is data1.csv. I can read it. Actually, I can rename and just call it employee file. So when I'm print employee file here, and it's gonna return everything in that file, which is their ID, their name, their age, their salary, their department, and their joining date. Alrighty. So there's a lot that we can do with this data, just for you to have a visual. So let's say, for example, I want to do, this is employee file perfect. I can do head employee underscore file and run it. It's gonna take it, just show me the first 6 files, and it's gonna tell me just for me to have a visual on what that file contains. You can do, if you want to view the structure of the data, just say str, then you can do employee file. I'll run it. It's going to tell you ID is an integer. It can tell you the name, the numbers, the integer, whatever. It gives you the structure of the file. Alrighty. And I can copy this one. Copy, then paste it here. Actually, I didn't copy it. So we can do a summary. Now, if you want to just see the summary of the statistics, you can just run it, and it can tell you the mean, the median, the max, the third quartile. It can tell you all it kind of do the summation for you, the aggregation for you, and to give you these statistical results. All right. Let's say you want to count missing values in each column. So you can use this command, sums is .na employee file. Close it. Let's see. It looks perfect to me. So there's no in ID there's no missing file, but in age there's a missing file, an item. So if I go scroll up right here, we can see we have an NA here in age. That's the reason, and another NA here. That's the reason we are getting this. All right. Let's say I want to remove the row that is missing an item. So I can do my employee file. na.omit. So Actually, I can do, let's say, something like data frame, then employee file. So you can begin to see that I can do some manipulations. I can start to do some manipulations, and I'm gonna print the data frame. Now those missing files are taken off because I omitted them here. So you can now begin to play around and do some basic manipulation, because before you even start to do your data visualization, you have to do a lot of cleaning of your data. Actually, it's a cycle in nature. You see that I'm missing this. I have to go work on my data. Either I have to add missing information, I have to remove missing information, whatever you want to do. So let's say you want to fill in missing information, you can use this command. You can say my data frame, which is edge on column edge. If it is empty, I want you to fill with a min. Then you can run it. Then actually, I need to take it out and run one more time. And restart the kernel, because it keeps it in memory. All right. Now I have to go over back here and run this one so that the other subsequent files can be run too. That's the only, I would say, drawback of Jupyter Notebook, because it it runs one code at a time. And if you want to, if another cell is dependent on another cell, you have to go back there and run everything so that it keeps it in memory. All right, you can filter data. You can, let's say you want people which are with an age above, let's say 25. You can filter them using this specific column, or by salary, or by department, or by joining date. You can do a lot of stuff here. So you can add new columns like I showed you earlier. You can group your data, you can rename columns. You can do a lot of stuff in this. All right. So now what you're gonna do is to import packages, and I will show you how it's done. All right. So now I've switched from Jupyter Notebook to an R Studio. Um, but you can perform the same thing in R Studio. It all depends on what you want to do, what you want to use. But we want to be flexible with all the tools. All right. So to install a package, all you need is to just say install packages and specify the package that you want. So we want to tidyverse. So I've already installed it. So I'm just going to get successfully unpacked. That's good. Then you can do library. If you have an error says add tools, go ahead to the POSIT website and that I showed you earlier, and download the R tools. Then you'll be able to install the packages. Okay, so we're gonna do library, then tidyverse. We just want to see the packages in tidyverse, and we can see we have deploy forecast, ggplot2, lubridet, pure read string tibu, and tidyr. Perfect. All right. So now we can begin to use this package to do our data science, data analysis. All right. Let's go ahead and do library tidyverse like what we did earlier. Perfect. And now let's create our data. We're going to do an employee data underscore data. And we're going to use the table one and open. So what I do, I just do create a space here. Now we want employee. I'm just gonna do 3 rows and columns here. Then we will do department. we will do also, let's say, performance scores. Performance underscore score. All right, so now we are going to go ahead and enter our data. So we want John, Mary. Let me do it this way, save time. Perfect. So we have 1, 2, 3, 4. You can limit it the way you want, but I just want to do it this way. And now let's go ahead and print the data, employee data. I'm going to run it. Employee data not found. Crazy. Run it. There you go. Employee data, John in HR, performance score 80, which is John HR 80, Daniel HR 89, Daniel HR 89. Perfect. So everything is fine for now. So that's a simple data frame. All right, let's now create an index. So I'm just going to save time a little bit here. And also, whilst we're here, we want to plot this data in a scatter plot. So we're going to use ggplot one more time. So ggplot employee data, then our x-axis, y-axis. Then at last, we want to print the plot. Print plot. I'm going to run it one more time. Argument X is missing. Alrighty, let's see what's going on here. All right. There you go. Went well. So, right, if you see to the right here, I've been able to plot the performance scores right here on the y-axis. On x-axis, I put the employee index. So you can see that IT department, you've got these variations, and now you can begin to see that HR is performing well. It's on the top. I would say these 5.0 all the way here, they perform better. And we have this IT department is not performing well. The finance, some elements in the finance department is not performing well. So that's how you begin to visualize data. This is just a simple one for you to see, but that's how you begin to visualize data using the R packages. So later we are going to do more complex ones, but for now, this is just a teaser for you to see that you can come up with a nice visualization. We're just playing with the tidyr package. All right, let's go ahead and move on to the next section.